system of the power sector. Basically, you are transporter of electricity from one location to the other location. We do not generate, we do not distribute also. We are only simply transporter. So, what we will be covering is a substation arrangement. There are different types of arrangements. Some of you might have visited Vishwanath Chorel. This batch, anybody gone there? Okay, you have seen the substation. So, it is a part of transmission system. We will be covering with the purpose of substation, single line diagram, busbar arrangements, and the substation layout. This is the first step of construction of any project. These are the basic first steps. What you understand, well, basically this is an interactive session. We generally take to the induction training whenever new engineers join in our organization, we conduct the training. So these are the presentation of those training modules. So it is basically interactive. My time frame is only 2 hours. It is a whole day session because interaction takes a lot of time. Here I will be speaking more, so I can finish it up early. Otherwise, it's a whole day session. Any idea about single line diagram? What is that? Why do you do the single line diagram? What is the purpose? Anybody? Quick answer because time is running.
To make a complex circuit simpler.
To
make a complex circuit simpler in a single line.
What do you understand by single diagram? Why we draw single line diagram?
Start to end.
It is nothing to do with electrical, nothing to do with civil. In every walk of life, single line diagrams is there. What is the purpose? It is the planning part. Only you just show the planning. If you want to construct a house, you first draw a single line diagram. हमारा एक bedroom इधर आएगा, दूसरा इधर आएगा. Here the balcony will be here. Simply a sketch you draw to represent the planning part only. With that you cannot construct the house or construct the station, anything. That is here just to express your planning, you have to draw a single line diagram. Then you convert to the engineering drawing, layout and section drawings, then you construct the. So single line diagram means you will simply show the planning part of the project. Basically what happens, earlier concept was that localized generation was there and localized transmission and distribution. Some area generation will happen, there will be generation and around only customers will be there. So power system was in 1956 and earlier also it was like that. But nowadays what happens, huge generation is required for which we have to create the big power stations. Big power stations means now hydel, suppose you go for the thermal or you go for the hydel projects. You cannot get the resource in the town wherever load center is, wherever the industry is there. You will not get coal, you will not get water. Your water will be somewhere in Arunachal Pradesh, your load will be somewhere in Bombay. Right? So you have to create the big power station based on the source, availability of the source. And then you have to transmit that entire. From Arunachal to Bombay, you have to transfer the power where industry is. So bigger station creation is the required. Today's power scenario demands creation of bigger stations. And obviously for that, high voltage transmission lines are required for transferring the power. Thus what happens now, from suppose I transfer power from Arunachal to Bombay, there are a lot of stages will be there where voltage is stepped out and stepped down. Different locations will be transforming the voltage for transmitting power with minimum loss. Why go for high voltage transmission? to reduce what?
Losses, transmission
To
loss.
reduce the losses.
Yes.
So somewhere we have to step up the voltage and do the transmission again. Somewhere we have to step down for consumption. So a lot of transformation has to be made in the process from generator to consumer. Thumb rule says that suppose your generator is 1 megawatt, almost 7 times transformation is required from generator to consumer. So many transformers will be in the system, almost 7 times, roughly. So lot of transformation is to be done. Just this is a picture, you just see the transmission distribution, just a picture. And all this transformation is done through substations. Substation, you find the transformers in the substation. So you have to create lot of substations in between consumer and right? Any question you can stop. Now segments of power system. One is generation, mostly NTPC, NHPC, NEPCO, these are the all generating companies. Then another is transmission, just like power grid in central sector, power grid is the transmission utility. Then distribution sectors are there.
APDCL, AECL.
And finally, what is the other component? Generation, transmission, distribution and
Consumption.
the third semester.
Consumption.
Load.
Load consumption.
Load is considered active as active or passive. What is active? What is passive?
Load is passive.
Load, do you consider it as active component of power system or passive?
Passive.
Passive.
Passive. Basically, earlier load was considered as a passive element of power system, but nowadays it is active. Why? Any idea?
Active component or what?
Those which consume power. Those which consume.
Any idea why load can be considered as active element of power system? Saving is considered as we have generator, which is helping the grid. Oil sector में क्या लिखा है? Energy saved is energy produced. If you can save energy, this can be considered that you have produced it. So by managing load, you can also contribute to the power system. So load is no more passive. Demand side management. What is that? You have to manage the demand side. If you can manage the demand side, lot of generation you can manage, which otherwise would have been required. Now in generation, you will find the two things. One is generating station and associated substation. There will be a substation attached to the generation. In transmission, you will find transmission lines and substation. In distribution system also you will find distribution lines and substation. And load, of course, there are two types of load. One is industrial, one is
Domestic.
domestic. Now we just see in every segment of power system, substation is there. In generating station also substation is there. In transmission system also substation is there. In distribution system also substation is there. This is a single line representation of power system. You will find the generation, transmission, distribution and load. Now, what is substation then? We have seen that substation is there in generating sector, transmission sector, distribution sector. So this is a subsidiary station. Basically, it's a subsidiary station to the electricity generation, transmission, and distribution. This is the mainly subsidiary station. Main station is generation, transmission, and distribution. But substation is a subsidiary station which is required for transformation and transfer of power. Electric power may flow through several substations between generating plant. As I already told you, there may be 7 times requirement capacity was for transmission of power from generator to the consumer. When we generate our power, it is at low voltage. Then we step up that power at high voltage. Then we go for transmission. Again, in the distribution side, we step down that power and step down to consuming the consumer level. And that is the way how power is utilized. So in the process, there are various steps where power will be stepped up and stepped down. And this step up and step down is done by the which equipment?
Transformer.
Transformer.
So if you are standing in front of a transformer, whether can you say whether it is a step up transformer or step down transformer? By seeing a transformer, can you say? Any idea? Asked. Replies to be asked.
Somebody would have noticed that TV can.
You are standing in front of a transformer. If you are asked whether it is a step up or step down transformer.
नोटिस को लिखा था किसी का
Huh?
Okay, but on the ground, you can't say no.
One will be high, one will be low.
Sir,
Any transformer.
sir, if the input is primary side is the low and the secondary side is high voltage, then we can say it is a step up. So in that way, the vice versa, we can say it is step down.
So by construction, a transformer is neither step up nor step down. It depends on, more or less your answer is right. It depends on the direction of power. If it is flowing from low voltage to high voltage side, it is in step up mode. It is the operational mode only. If it is flowing from high voltage side to low voltage side, it is step down mode. So same transformer can work as a step up transformer as well as step down transformer depending on the
number of times.
direction of power. In integrated system, power can flow in both directions, right? From Vishwanath Charoli to Agra it can flow, from Agra to Vishwanath Charoli also it can flow. So direction may change. So depending on the direction of power, the mode of operation of transformer can be either step up or step down. By construction, any transformer will have a low voltage coil and a high voltage. So by itself, transformer is neither step up nor step down. Only mode of operation will decide whether it is working in step up mode or step down. So these are very, very basic things. Have you seen distribution box? Distribution box, have you seen? Anybody? हर जगह होता है, everywhere it is available. In this building, all of distribution boards are there.
Sure, MCB.
Hmm? Nobody is seen.
Yes.
This entire electrification done through a distribution board.
MCB.
It is everywhere it is. In your own house also it is.
Yes, sir.
Fine. What is there inside the box?
MCB, TFC, MCB, TFC.
What is there inside a distribution board?
Fuse MCB this RCCB ऐसे तुम्हारे इंडस्ट्री
MCCBs.
MCB
MCBs.
MCBs and switches are there.
3 switch
Right. So this is distribution board. So these are the MCBs. And there is
wires
some strips are there. Only MCB is not there. After MCB, you will find some metallic strip is there, where you will be connecting all the wires together, right? Okay. These strips are used for common point of connectivity. And all the circuits will get connected to that common point. My request is that please switch to the mobile or make it silent. So these strips are known as busbar strips. Now suppose there is a cable connected to the busbar like this. Okay? And there is another cable like this. Can there be any flow of power between these two cables? Can there be exchange of power?
No.
Cable means circuit. Is it possible?
No, sir.
Huh?
No, sir.
Why?
Because, sir,
connection will be start
both are on the same voltage difference. So there is no-
They are not connected in common point of connectivity. They are not in the same pattern. So there is no connectivity between these two cables. And so exchange of power is not possible. Only it will be possible when they will be connected in same common point. Once you connect them in the common point, there will be flow, exchange of power will be possible. Right? Likewise, all the cables if connected, power exchange will be possible. So your substation is also a distribution board. You replace all the cable by transmission lines. You will find a bus bar, common point of connectivity. All MCBs replaced by circuit breakers. You find a substation and distribution. General distribution board is same thing.
on ऐसे करो animation को
Any disagreement? किसी का भी कोई disagreement हो? Mandatory that for exchange of power between the circuits, there should be a common point of connectivity. And that common point is known as bus bar. Just check your books, you'll find that definition. Definition of bus bar.
replacement level replacement level क्या लगेगा
Now we'll see the general arrangement of substation. How we arrange the substation. Suppose there are three circuits. This is a single line diagram because each circuit is having three phases. And I have shown only one phase, one line, single line diagram. Otherwise, I will have three different phases for each circuit. Instead of drawing 9 lines, I have drawn 3 lines. Now, can there be exchange of power between these circuits?
No. No, sir.
Because they are
Ideal.
not connected in common point. So my first requirement will be, let us create the facility. Now we are building up a station one by step. First requirement is power flow. So what we have to do for that? The first requirement, three circuits are all plus.
Connect to a common point.
My first requirement is that there should be flow of power between the circuits. For that, what is to be done? You have to construct once you construct the bus bar, exchange of power is possible. Right? Now let us see what are the next requirements come one by priority. In any asset, you forget this electrical engineering. In any asset, maybe your refrigerator, maybe your washing machine, your TV, whatever. Any asset. What is the requirement? What are the different requirements you want? First, you purchase a washing machine, TV, it should be operational. It should be capable of doing operation. When you want to switch it off, you should be switch it off. When you switch on, switch off, when the facilities is required. That facilities is called the operational system. That is the first requirement of any asset. You purchase a TV, it is continuously running. It do not have operational. Cannot switch it. Only require that any asset you require the first priority is you have to have the operation facilities. So now it is there is no operational facility, continuous flow of power is happening. How to incorporate the operational facilities? What is to be done?
Switches.
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 So we have to put
Switch.
switches. In ESB, circuit breaker is a switch. Right? Isolator. Is isolator a switch?
Open. Isolator ne container
Huh? See, by name of the equipment, you understand the functions also. Circuit breakers mean it can break a circuit. Running live circuit, it can break. But isolator means isolation. Only you can isolate, not the break. If you break a circuit, lot of arc will be forming. So if it is not extinguished, there will be fire hazard. So that can be taken care of by circuit breaker. Because the arc quenching media is there inside. But isolator is meant for isolation of the system. So operational feature you can create by incorporation of circuit breakers. Now exchange of power is possible in this system and operation is also possible. Now what is the next feature required in any asset? Next priority care. Hmm? Next priority. Any asset, what should be the priority? In any asset, if you do not do the maintenance,
Maintenance.
that will
Lightning arrestor and then also.
die soon. So you have to have some maintenance facilities. Without maintenance, nothing can survive. So next facility requirement is maintenance. For which what is required? For maintenance, what is required? Suppose you are circuit breaker, you want to do the maintenance. Can you do right now in this condition? Can you do?
No.
No.
Can you carry out maintenance of the circuit breaker in
No.
this position?
No.
No.
Hmm?
No.
No.
Yes or no?
No.
Huh?
No.
No. No.
No, because you will be exposed to high voltage. So you need for isolation. You require to isolate the equipment for doing the maintenance. For isolation purpose, we have to put
Isolated.
isolators and
Hard face.
arc. You open the circuit breaker, it will be dead. Then you open the isolator, circuit breaker will be totally isolated from the entire EHV system. Then you do the maintenance. So this is the reason why isolators are good. For isolation of the segments of the some of the portions of the station where individual will do the maintenance. Otherwise, it will be hazardous. It is not possible to do the maintenance. Next requirement is protection. Any asset you create, you have to have some protection, otherwise it will get damaged.
Lightning arrestor.
Because there are a lot of external enemies out there. So your asset is exposed to that. You have to protect them from those enemies. For that, what we will do? We will install lightning arresters. Lightning arresters, external enemies are lightning and all this thing. They travel along with the transmission line, and once they enter inside the substation, they damage the entire winding, transformer, equipment, failures. So you have to cross those enemies. So at the beginning, at the entry point, you will put the lightning arresters, so that anything coming from outside, they are just like security. Where you put the security? In the boundary wall, not inside the construction. They are placed in the boundary. So all transmission line, when entering a substation, first equipment will be lightning arrestor, so that any traveling waves, everything coming to the line, to the substation, first they will encounter lightning arrestor and get trained. This is the way how your asset is protected. Next requirement will be measurement. Why? Why you go for measurement? Because
Know the current value, voltage value.
Know the parameters.
this is the asset we are creating
CPCT like that.
Not for-
Transformer.
So social purpose, right? It's a commercial purpose. So anything commercial means you have to set some measurements. If you give money to someone, you do not simply give the money, you count and give. Here also we have to count how much energy you are selling, how much energy you are buying. So that measurements is required, otherwise your asset will not be feasible commercially. So for measurement, what is required? How you measure power?
Watt meter.
Hey, CPCT.
You will measuring power only, na?
Current transformer and potential transformer. Energy
How is it is measured? What is the component required for power measurement?
Watt
What is
meter.
the formula of active power?
VI cos phi.
Hmm?
VI cos phi.
Yeah, question.
CPCT.
Very close, na? So you need voltage, you need current. In the primary, what is the current, what is the voltage, that you need. And you cannot directly measure from primary because it is a high voltage. So you have to step down that voltage in the measurement level
Current transformer and potential
and
transformer.
connect energy meter that will read the
Current transformer act like a emitter,
calculate the-
potential transformer act like a voltmeter. You should value.
So for
you should get the
stepping
value
for
V
current
and I,
purpose,
then you
you
should
put
know the energy.
current
Sorry,
transformer,
power value.
right? That will give the current, reflected current from primary to secondary. And for voltage, you'll put CVTs. So they will convert the primary voltage and current to measurable level, and those inputs will be given to the meters that will read the. Somehow you will find busbar in PTs also will find potential transformer that will also serve the same purpose. It will give the voltage. And from current you will get from CT. Automatically angle difference of current and voltage will be calculated by the meter cos phi. And root 3 is the absolute value. So root 3 VI cos phi automatically meter will calculate if voltage and current input is given. So next, communication and teleprotection. Anyway, teleprotection is a different subject altogether. Next, you require a communication facilities because end-to-end communication is required. Suppose there is a connection between Vishwanath Charoli and Balipur, and direct connection is there,
Key use
and there is no communication between these two stations.
component.
So there are no accidents.
No.
So I am charging the line.
Fiber.
Lot of mismatch of operation.
Major আছে
So we have some dedicated communication between the station and the.
উপর যারা লাগি থাকে ওয়্যারটা
For which we use generally power line carrier communications. Where we, you have studied modulation of demodulation of signals. What is modulation and demodulation? Carrier signals.
They mix it with appropriate frequency for transmission.
They are from final year. No? 6 months.
4
Anyway, in the higher semesters, you will study.
They mix it with appropriate frequency, high frequency for transmission.
Okay. I think final year comes out.
balance basically and that is the
Anyway, but this is the last thing is the
Frequency for,
communication
like,
facilities.
মানে
right?
ইলেকট্রিক সিস্টেমত
Where
যোনটো মানে তোৰ
frequency signals are
আয়াৰটিং
used
লাইন
for
থাকে ন ওপৰত
communication
সেইটো
purpose.
দি কমিউনিকেশ্যন কৰে
And same transmission line is used for
Mhm.
transfer of the
Execution
signals.
কি
For
কৈছিলে
which we require
frequency use করে.
some web trucks using which we can
এতিয়া হ্যাঁ পাইছে
extend the communication. Which is the step. You have come across all these equipments what I'm naming.
Here you did this following. First, the vital activity is not provided before the transformer, only after transformer. Second, the wave trap should come before the CB.
No, it will block, na? See.
Intellectual versus intellectual.
Your first question is that.
এটা আচ্ছা এটা ভিডিওটা রেকর্ড করে
Can make it bigger.
হ্যাঁ ভুক লাগিছে বে ওয়েব ট্রিপ শুনলাম যে ওয়েব যে মডুলেশন করে হাই ফ্রিকোয়েন্সি
আচ্ছা
Some of registration here, right? Word trap.
মডুলেশন বানিয়েছে
Is it okay?
Adjustment to ask the question. Second adjustment may not answer question. Adjustment may not.
So suppose this is steering.
Don't be afraid to ask.
Now you are running this is steering.
बस सर हमको पानी पिला दीजिए हम पूछ लेगा बस हमको पानी पिला देगा हम क्वेश्चन पूछ लेगा भाई
Here also this is steering.
पानी पिला दीजिए रिफ्रेशमेंट दे दीजिए
NSS refreshment data.
This is 8 shape point. This is a high frequency point. Somewhere will take the communication. From here you will going to the fifth.
Technical outside guy.
सब कुछ हमारे एडमिशन फीस को मिल रहा है
57,000.
So someone speaks.
पावर पॉइंट कैरियर
Voice
कम्युनिकेशन
communication is there.
पावर पॉइंट
So this
पावर
will
लाइन
be-
कैरियर कम्युनिकेशन
Here modulated. And carrier will be added. That will transfer the signal. So after modulation, this signal will be added with carrier signal. So high frequency signal. Very interesting. So this will travel through CVT because CVT is a low impedance part for the high frequency. So once it lands up here, we do not intend that it should go to the substation. It should go to the other end. So here the high frequency signal are two parts. One is this side, but if it starts traveling this side, wave trap will slow. Because for wave trap, for high frequency, the wave trap is a very high impedance. So naturally it will follow here. High frequency signal will transfer like this. And once again here lands, you will have two options. One is low impedance path, one is high impedance. So automatically it will follow the low impedance path. Here demodulation will be there. And person over here will listen whatever he is.
डिपार्टमेंट तक मिल रहा है
This is the reason why CVT is before.
Or see the both frequencies.
Huh?
No,
Yeah, both the frequencies
The
traveling.
power-
Yes, power is also traveling 50 Hz.
the power and the communication both coming at the same.
Same
the
conduct, same conduct.
Same. So first it will enter into the substation. So first.
Now for high frequency signal, wave trap is a problem. For low frequency signal, 50 Hz is a low frequency.
No problem.
No problem. Automatically power is from substation to substation power.
If you can look for the power end, from where this power is coming, and the both signals are coming at simultaneously. So first it will get the wave trap. From here it will.
Suppose from this station power is transferred.
along with
power.
the communication signal.
This is power.
Along with the communication signal.
This is communication signal will come like this.
सिविल का काम है अभी तक समझ नहीं
हाँ
Both
भाई
will
तुम
mix
क्यों
here,
आए
but they will not mix
कौन
because
बुलाया?
the modulation demodulation.
कोई
Here
बात
this
नहीं।
line cannot do the modulation and demodulation. That is to be done in the
सबका
PLC.
काम होता है यहाँ पे
Only your voice and carrier can be mixed in the PLC. Here the signals will not mix. 50 Hz is also traveling, communication is also traveling. But here, once both the signals are for 50 Hz, there is no issue, you simply go there. But for 50 Hz, this is a very high frequency. CVT is a very high frequency.
Where is the frequency of this?
Yes, yes. Because,
So, note A, no substation. Where is the substation actually?
this is a substation. Location A. This is another substation location. They may be
कॉन्सेप्ट
500
बोला सर
kilometers away.
कॉन्सेप्ट बोला एक्चुअली आम्ही এনেকে পোৱা নাছিলোঁ ৱেব ট্ৰেপটো চাই ঠিকে কথা কৈছে
In between transmission line.
Is it transmission line?
In between transmission.
Is it transmission line?
Make it DSL.
What about the lamp resistance? The transmission line
In
model.
the wave trap, both the
this
this inductor and the capacitor.
Here it will get two parts. Na? One is the inductive and capacitor.
So in the wave trap, both the inductor and capacitor are in class.
प्राइवेटली
But that capacitor is tuning capacitor. That
Tuning
will tune the particular band there. That is not the blocking capacitor. That is the W and C, we have to L and C tuning capacitor. So the particular band of signal, communication signal, we will allow other band it will be.
Concept here, every person. Like engineer to miss
Other of noise will be there. All signals is
মোলে
processed.
কাৰণ চাই সুধি আছে ন
Some band
বুজাই
is
আছে
to be tuned. So inside
that
small
we can give on this one. Now very soon to the web trap to figure out.
Have you covered this thing? That Saraj code?
यस
Yes.
यस
Huh?
Yes, sir.
And LA should be fast because all that lightning, suppose there is a lightning stroke comes over here, so traveling wave will be there. Fast equipment should be LA. So that it trains. Fast
আৰু
equipment.
নিউজটো ফাৰ্ষ্ট কৰি আমাৰ নিউজ বহুত ভাল হয় ইলেক্ট্ৰিকেলৰ কাৰণে
So the reason fast.
মই নক'লোঁ একমাত্ৰ বহুত দূৰ হয় আৰু মানে অৰুণাচলৰ যায়
Lightning frequency high.
Nervous.
Lightning is very high. It damages the insulation.
So it will go near a capacitor.
The lightning, these are the LAs of the non-linear resistors are there. It will give a low impedance path for high voltage.
That's the capacitor.
No, path is resistive. Totally third harmonic resistance is there. These are resistance. It will no, voltage. This is not nothing to do with frequency. If there is a voltage rise, suppose there is a lightning, there is a sudden peak will be there. So further LA will be the low resistance path, so it will drain. Once again voltage falls down, again it will give a high resistance. This is the way how it is. So this is all the facilities required. Operation, maintenance, protection, measurement, communication. Now I can start my business. Once it is created, we can start the business.
বিজনেছ কৰিব এতিয়া
So this is the general arrangement of substation. Now we'll see how by changing different arrangement, lot of reliability and all these things can be changed in future. This is the general arrangement that I am telling. In coming slides, since position of lightning arrestor cannot be changed, it will remain there only. Position of equipment we cannot change. Other than the switches, to create different facilities, we have to rearrange the switches. The position of LA at the beginning will be there in always because your security should be at boundary only, periphery only. It cannot be put inside the complex. So their position of LA, CVT, wave trap, city will not change. So we will not show in the coming slides where we will show the arrangement, different busbar arrangements. Only switches means isolator, breaker and busbar. These are the three things I will show. And different arrangement you will find the different facilities. So before we go, anybody has any question you can ask?
কোনোবা আন্ধাৰতে কৰি আছে কৈছোঁ